Hi, it's Mr. Kane here, and we're going to look at the periodic table and how it's put together and some of the key things that's useful to know about it, and so you can sort of explain. You should know by the end of this why it looks the way it does, why it's the shape it is. So we can organise or classify elements in several different ways. How nature did it, so naturally occurring ones, ones that are man-made by scientists, or should I say person-made, sorry, they're made by scientists. Solid, liquid or gas, what state are they in? Or they metal or a non-metal? These are all different ways of classifying elements, and they all link together on the periodic table. So there is the modern table, how it's all laid out. It's laid out in this style to satisfy many things. We'll go through it in this video, but the group at the bottom, this group down, where are we, little pen, this group down here, this is the lanthanide series, and it slots into this gap here, and the reason they tuck it down the bottom is so that the table doesn't get too wide and actually will fit on one page. Alright, so the table lists all the elements in increasing atomic number. We start with number 1, 2, 3, 4, and so on up we go. And it puts all those with similar properties, they behave the same way, they react the same way, in groups, in the vertical columns. Okay, so all the elements in one group have they behave in a similar way, as they have the same number of outside electrons. Their valence shell has the same number of outer electrons in it. So looking at our table, that's the rows or periods on the table. Each of those ones equates to a electron shell or layer around the nucleus. So all the elements in this first row here, they just have one shell. These has 2 shells, 3 shells, 4 shells of electrons, and so on this way. And those are the groups. Each of the groups, or those columns in the table, have the same number of electrons in the outside shell. So over here we've got group 1, so it's 1 outside electron. Group 2 has 2 outside electrons. Over here group 8A or 18, their outside shell is full. This one here, we've either got 7 or the 17 in the outside shell, depending on which layer we've gone to. So the first 2 layers here, they'll have 7 in their outside shell. We go down to the next one here, they'll have 17, and so on down that way. And the families on the table, so the columns, they're grouped into families, so groups of chemicals that behave the same way, groups of columns that the same way. It could be one column, could be several columns put together. So it becomes a family, and they've been given names rather than numbers, just like your family will have a name. So for example, we have the alkali metals, the alkali earth metals, the halogens, the noble gases, and there's others in between that we'll meet soon. So alkali metals, really reactive, and they're really soft as well. The earth metals, now we're going to get through these pretty quick because there's a heap of them. Okay, they're also very reactive, but very useful mineral nutrients. You know, magnesium, we need that, calcium, we need that in our bones and stuff. So very reactive. They always bind with something else, but they're also useful in minerals for us. So milks and cheeses and things. Okay, transition metals, that's sort of the rest. Quite a few, so groups 3 to 12. And these are like sort of your actual real metals, the ones actually used for building stuff with. So the metals make up the left-hand side of the table. They've got, well, extra electrons is a bit misleading. Their outer shell might have 1 or 2, only a few electrons in it. So they're like sort of extra. We'll find out more about that soon. They are conductive, so electricity passes through. Malleable, you can pound them into different shapes. So plug them in, beat them into different shapes. they're pretty dense, they'll sink, they're shiny, and they're ductile. So shiny coins, solid things, and you can ductile means you can pull it out into a wire, and they're found in that part of the table. That's all your metals over on that side there. So their outer shell has only got a few electrons in it, and they're quite keen to get rid of them actually. So they react like this. As you go from right to left, they become more reactive, and as you go down the table, they become more reactive as well. So for example, over here, where are we? Lithium will be more reactive than aluminium, and potassium will be more reactive than lithium. And we can create a reactivity series from quite reactive to less reactive to quite reactive, or the other way around. So down the bottom, platinum, gold, silver, they're very unreactive. At the top we've got potassium, sodium, calcium, which are quite reactive. Okay, non-metals. These guys missing electrons, they haven't lost any, just means that their outside shell is almost full, so they're sort of missing one or two to fill it right up. They don't conduct, you can't beat them into shape, and they're not very shiny, they're dull, and that's them over there. And then we've got the ones in between, the metalloids. Some conduct, or they conduct sort of, not very well, and that's those few there in between the metalloids. So we've got the non-metal family, we've got the carbon. That's quite an important group, as you know, we're known as the carbon-based life form. So that's us, and it's its own branch of chemistry, you know, carbon chemistry. Nitrogens, most of our atmosphere is made up of nitrogen. That's all the gas and stuff around us. It's pretty hard to get hold of if you're a living thing, but it is very important in our chemistry. The oxygen family, well, we breathe that, we need that for respiration, and this group also contains sulfur, and anything that smells bad, it's got sulfur in there. And the halogens, these are really reactive, group 17, so they're really reactive, so they're always found combined with something else, and we use these as cleaners because they're quite good at killing off bacteria and stuff. Put them in pools, brush them on your teeth, keep things clean, disinfectants, sterilising solutions, and so on. And then we've got the what's called the noble gases at the very right hand side of the table. Their outside shell is full. They're very non-reactive, they're very happy because they're electrically neutral and their outer shell is full up. And that's them over there. That's the noble gases. So we get to use those in lights. They use them in balloons to make them float. They've got a very full valence shell and very unreactive because of that. So that is the periodic table, and I hope that's a pretty quick tour, but I hope that was helpful. If you need to look at more, just go back and replay the video and pause at various places, and yeah, hope that was helpful.